Hello and hi once again. That doesn't make sense, but anyway, so in today's video we will now distribute the base shear that we have solved for in the previous video to each of the stories here, so to each of the floors. So in doing so, we would be making use of this section in NSCP, so that is section 208.5.2.3, or the vertical distribution of force. So you can either memorize these formulas or you can do it my way, wherein I have only memorized this formula in the middle and I just understood the concept between this formula at the top and this formula at the bottom part. Okay, so let us just understand them better. So as for this equation here, saying that V is equal to Ft plus the summation of Fi with limits I is equal to 1 up until N. So what this equation means is that the total base shear, so V, should be equal to Ft, whereas Ft is the concentrated force at the top, plus the summation of, well, the distributed force. So in other words, or in a graphical representation of it, so your base shear V, and that is, well, this one here. And by the way, this 1806.46 was already solved for in the previous video. So if you want to learn more about that, then rewatch the previous video. So the total base shear 1806.46 kilonewtons must be equal to all of these forces on the right. So Ft, this Ft here is this blue line here, and the summation of Fi's here are the ones drawn in green. So once again, in other words, this total base shear here should be equal to all of this, whereas Ft, so this is the concentrated force at the top, and this one. So this one is all of these green forces here. But what is Ft? So Ft is the concentrated force Ft at the top. And as you can see, this is the force at the top. So Ft is equal to 0.07 times T, which is the period, and we have already solved for the period last video. And V is also the base shear. But we have two conditions here. So Ft should not exceed 25% of the base shear and may be considered as 0 if the period is 0.7 seconds or less. So in other words, we will only make use of Ft if, let's say that if T is greater than 0.7 seconds, it means that we will now be, so Ft is not equal to 0 and we will be solving for the value of Ft. But if your period is less than 0.7 seconds, it means that Ft is equal to 0 and thus is negligible. So with that, if your period is less than 0.7 seconds, you can now erase this part of the equation. So with that, your base shear is now equal to the summation of this, or the summation of our green vectors at the right parts of your screen. Okay, so there. So before proceeding here, let us first check if we need to solve for Ft. So I have already pre-made a table because it is easier to do it this way. So as you can see here, for the value of our force x, or the force to each of these elements, it is written as V minus Ft times Wxhx divided by the summation of all the products of the weight times the height. Okay, so as you can see, it is dependent upon the relative height and the weight of each story. So from the previous video, we have already indicated here that the weight of the floor is estimated to be 1,950 kilonewtons and the roof deck weighs less at about 1,600 kilonewtons. So I have already written them here. Typewritten them in this table. So let me just increase the size for you to see it better. Okay, so here. So as you can see, for the first floor, its weight is 1,950. And for the height, of course, since our first floor is located at the ground level, its height is now to be equal to 0. And as for the second level, so the second level is located here. And if it is located there, it means that its height is equal to 3.5. So 3.5. And thus, it will be increasing by 3.5 up until you reach the roof deck. So this is the total height of the building. Okay, so like what I have said a while ago, that the ratio here is dependent upon the product of the weight and the height. So, by the way guys, you can just solve for it this way and not memorize this formula. Papakita ko na lang sa inyo mamaya main concept. But let us just multiply this. So, 1950 times 0, this is 0. So, let me just change our color. So, 1950 times 0, this is equal to 0. And 1950 times 3.5, looking at the calculator. So, 1950 times 3.5. So, that is 6825. So, times... So, I would just be typing 1950 times alpha x. Then, I will be pressing calc for every time. So, calc 3.5. So, that is 6825. So, calc, what is the value of x? So, that is 7. So, this is now equal to 13650. And what is the value if I would be clicking calc again, then type 10.5, which indicates 10.5 here. So, equals, so 20475. Then I will be proceeding to all of the doors. Then for the final level, I will be multiplying 52.5 and 1,600. So 1,600 times 52.5. So that is 8,400. I mean 84,000 I should say. So I will be getting the total of this. So as to why, because that is actually needed. Okay, so that is basically this particular value here. So let me show you later what is the importance of that. Okay, so once again, I would just be getting the total of all of this. So that is 6825 plus 150 plus 2475 plus 27300 plus 3415 plus 40950 plus 47775 plus 54600 plus 6145 plus 6250 plus 75075 plus 81900 plus 8725 plus 9550 plus 84,000. So the total is 800,625 kilonewton meter. So by the way, these are the values for your WI and these are the values for your HI. So this is basically WI. So this is WI times HI and the unit here is kilonewton meter. And as you can see, so this is WIHI. And this one here is the summation of all of the products of WIHI. So there. So what is the importance there? And we will be making use of this value in order for us to distribute whatever needs to be distributed. Okay, so for the value of FT first, so let us check if we need to solve for the value for FT. So previously, we have already solved for the period. So the period would be as follows. So using method A, we have already solved that the period is equal to 1.664 seconds. And thus, going back to our parameters here, that FT need not exceed 0.25 base shear and may be considered as 0 where T is 0.7 seconds or less. And since our period, which is 1.664, is greater than 0.7, it means that we must solve for the value of FT first. So for the value of FT, so I would just be writing them on top, or let's say I would just be writing it beside it here already. So I wouldn't be writing the solution for it. Just look at the calculator to your left. So FT is equal to 0.07 times the period, which is 1.664, I should say. I think. So 1.664 So 0.07 times T times V. So what is V? That is the total base shear. So 1806.46. So times 1806.46. So that is now equal to 210.416. So 210.416. And once again, this is the concentrated force at the top. So in this figure, so Ft is equal to 210.416. So that is just for this blue line according to NSCP. So that is 210.416. Okay, so what about for these green lines here? So whatever is left, if you would be subtracting 210.416 by this one, it should be distributed to all of this in proper ratio, of course. Okay, so with that, so the difference between V and this one, so I will just be writing them here. So suppose that V is equal to 1806.46 and that Ft is equal to 210.416. So if I am to subtract both of this, so 1806.46, so V minus Ft, so if I am to subtract them, we would now be arriving at an answer of, so 1806.46 minus 210.416, our answer here would be 1596.044 kilonewtons. So what that means is that all of these forces or all of these green loads here will now come from 1596.044 or vice versa. So we can say that this 1596.044 will now be distributed to all of these green vectors. And in order for us to do that, we will be making use of this equation, whereas this is basically V minus Ft. Then we will be getting just all of these ratios. So how can we distribute them? So it is, well, fairly basic. So just get this value and just multiply them by the ratio of the product of the weight and the height of each floor to the total. So it would be as simple as that. So in other words, so I would just be writing them here. So 1596.044 times the ratio of this one, of whatever floor that you are analyzing. So let's say Wi Hi divided by the total. So divided by this. So this is now equal to 800625. So it would be as simple as that. So looking at the calculator to your left, so 1596.044 times, so the ratio of whatever our answer here is, so I would just be clicking alpha x here, and divided by 800625. So this is the total of all of the products of the weights and the relative height. Okay, so if I would be pressing calc and I want to know the story shear at the ground floor, so 0, so I would just be substituting 0 here, and of course our answer here is also 0. So this is also 0. And as for the second floor, so of course I would be substituting 6825 here, or this one. And why did I do that? So I would just be clicking alpha x. So click calc and I would be typing 6825. So this is now equal to 13.6056 kilonewtons. So press calc once again. So our next one here is 13650, and our answer here would be 27.2112. So that is for this one. And as for the next one, that is for 4, I would be clicking calc once again, and I would be typing 20475. So that is now equal to 40.8169. So on to the next. So calc 27300, and our answer here would be 54.4225 kilonewtons. Then I would be solving for it once again. I mean, solving for the next one. So this is now equal to 34125. So this is now equal to 68.0281. On to the next. So calc 4095. And so on. Okay, so once again, if you can remember for the roof deck or the final one, so the story here, or the, let's say the force that will be concentrated here will be Ft plus Fn. Because of course, we have both of these vectors or these forces going to the same direction. So for Fn here, so that is basically the total base shear, or 1596.044 times 8,400. I mean 84,000 divided by 800,625. However, we must add Ft of course, because once again, kasama po yan, magkasama po sila. Okay, so let's say that this is now to be the force at the roof deck. So let's say FRD is equal to, so this is for the value for your Fn. So you would be you would be adding the value for Ft right now. So Ft is 210.46. So 210.416, I should say. Okay, so why did I do that once again? Because of course, the force that is acting on this level is the combination of Ft and Fn. So just add them. So looking at the calculator to your left, so this is now to be 84,000, or 1596.044 plus 84,000 divided by 800,625. Okay, so 167.454 or 45, because it is not showing in the screen any longer. So 167.54, and if you would be adding 210.416, so plus 210.416, so the total here, so the total force here is equal to, well, 377. So with that, this is now equal to 377.87. Okay, so these are the values of all of this, of course. So by the way, take note here that this force is inclusive of Ft already. So in Tagalog, in Filipino, dito po sa value na yan, kasama na po yung Ft. So sinama ko na po. Okay, so in order for you to know if your answer is correct, just get this total value. And these values, I mean the total of this value should be equal to the total base shear, which is this. So pag kukunin mo po yung total na lahat, dapat po exactly like that. So our answer here is 1806.4597, which is 1806.46. So with that, I can now conclude that my computation here is correct. So V, or the total, is equal to 1806.46, which is exactly equal to the computed base shear. So that is how you would be distributing base shear onto all of the floors. So as a recap, you must first, of course, check if you need to solve for the value of ft by checking the period that you have solved. So if it is greater than 0.7 seconds, it means that you need to solve for ft. But if it is less than 0.7 seconds, then disregard the effect of ft. Oh, and another thing that I forgot to include here, that it must not exceed 0.25 V. Okay, so 0.25 of 1806.46 is equal to 451.615. So, as you can see, that our ft is not greater than that value, it means that we will be making use of this value. But if not, for example, that 0.25V is less than the value that you have solved, then you will be making use of 0.25V. Okay, so after checking the value for your ft, so after solving for it, you will now be deducting this value from the base shear for you to know what is the force that you will be distributing to each of the levels. So there, and after solving for this, you will now be once again distributing, you will now distribute this value to each of these stories by virtue of this formula. So that formula is equal to whatever shear is remaining times the product of weight and height per story. So suppose that you're analyzing the first story, then you will be making use of this value and divide it by the total. And let's say that if you are solving for the shear at the 5th floor, then get the product of the weight and the height of the 5th floor, then divide it by, of course, the total of all of the products of the weights and the heights. Then multiply it, of course, by the base shear. So there. And by graphically representing it, it would now look like this. So this is now the value for your ft, whereas that is the value of 0.07 TV. And as for these green ones here, yun po ito. So these are these values. But take note that the value that I have solved for here, which is 377.87, is already the combination of both of these. Or ft is equal to 210.416 plus 167.65. Okay, so that is it for today's video lecture. And study well.